Hi there. So this question really sums up all of the things we've been learning about linear functions and analytic geometry. This question that you have in front of you is super similar to the types that show up on the final exam as a 10-mark question. It looks very simple, and it actually is, but you're combining some of your knowledge from linear functions and from analytic geometry in order to solve it. Let's look at what's given in the question. First, we have two lines in the Cartesian plane. We have line AB and line CD. What's written up here is AB and then this interesting symbol here that looks like an upside down T, and that means perpendicular. So AB is perpendicular to CD. In case you weren't aware, that's the perpendicular symbol, and in other questions of a similar type, sometimes you'll see this small symbol, which means parallel. But for this question, AB is perpendicular to CD, and you can see that because there's a right angle drawn in at the intersection between CD and AB. From point A, point C is located 3/4 of the way along line segment AB. So that's telling us a little bit about point of division because there's nowhere else in the course where a fraction is given in a question. As well, it's giving us a distance along the way, which is quite helpful. And point D is located on the y-axis, and you can see that over here with point D sitting right there on the y-axis. And the question is, what are the coordinates of point D? So let's begin with the first things that we know. Why would they give us that AB is perpendicular to CD? Well, something's really interesting about CD, and it's that we don't know anything about it. We have no idea what the coordinates of point C are, and so it's really difficult to find out any information about where C to D might intersect the y-axis. The other thing is in order to know that, we would have to have an equation in the form y equals ax plus b in order to find out our y-intercept, b being our y-intercept. So in order to do that, we need the slope of line C to D. Well, we're getting a little bit of a hint here when we see that AB is perpendicular to CD because, as we explored in a previous video, perpendicular slopes have a special relationship, and that they're negative reciprocals. And so if we find out the slope of A to B, we can change it into the slope for C to D by doing a negative reciprocal. So I'm going to start with that. What is the slope from A to B? Well, our formula for slope is y2 minus y1 over x2 minus x1. When we're determining slope, it doesn't matter which coordinate pair is x1, y1, and which one is x2, y2. As such, I label them left to right, and I also tend to label them in alphabetical order. So here we go, 275 minus 775 for the y values, and 550 minus 150 for our x values. And that gives us an interesting slope. So on top, 275 minus 775 is negative 500. And 550 minus 150 gives us 400. Now you can see that this negative 500 over 400 is a very large fraction. If you're not comfortable with reducing that just by yourself, you can use the fraction button on your calculator to do a reduction for you. For this one, I see it's quite easy because they're just zeros, so 500 over 400 is the same thing as 5 over 4, or in this case, negative 5 over 4. Now, to convert that slope, I want the slope of CD. I'm going to have to say, well, I need a negative reciprocal. So I'm going to do my flip it and change the sign approach. So flipping it over and changing the sign. So now I know that the slope for my line over here from C to D is going to be 4/5. So that's really handy. Now the next thing I'm interested in is finding out point C, because I don't have any points sitting on the line still, and sure enough they give us a little information in the second bullet. So let's find the location of C, and I'm going to just put a little subheading down here. To do that, we need our division point formula, which is x1 plus a over b x2 minus x1, and the same for y, y1 plus a over b y2 minus y1. And here we go. Let's look at our x1, y1 has to be point A because it's from point A, and they also named the line segment AB. So we can use the same labels for A and B. So 150 plus 3/4 x2 minus x1 put a comma. Do the same for your y coordinate. y2, 275 minus 775. And here we go. Now, don't forget the bed mass. People make a big mistake. 550 minus 150 is 400. $275 minus 775 is negative 500. Now don't forget, you have to multiply these guys out first. So 3/4 times 400 gives us 300. And 3/4 times negative 500 is going to give us 375, or negative 375, because there's a negative 500. And when I finally add those two numbers up, the answer I get, I'm a little bit out of room here, is 450 and 400. So those are my values for point C, which is perfect. So now I have a point on the line and I have the slope of the line. And so we can substitute that back in to find our value of B. So we have a value of A, we have a value of X, we have a value of Y. And so now we're going to do this by finding our rule, and embedded in that rule is our y-intercept. So I'm going to take this little spot kind of down here on our page and say we're going to find the rule for CD. And here we go. So I'm just going to do a plain substitution. We have a y value, which is 400. We have an a value, which is 4/5 that we just found. We have an x value, which is 450. And we don't have a b value, which is our b value is our y-intercept, and sure enough, that's what point D is. So that's great. I'm going to leave that 400 on this side for a second and do 4/5 times 450 to find out what that number is, and it's 360. And you can see here that we have some adding and subtracting going on, And so what I'm going to do is subtract 360 from both sides, because it's being added and subtracted, and our b value therefore is 40. So now we know our rule for line CD is, so our rule is y equals 4/5 x plus 40. Now why does that matter? What does it even mean? Why it matters is that means this point here on the line where D is 40. Now it says what are the coordinates of point D? Well, since it's a y-intercept, we know all y-intercepts have an x value that equals 0. So our value of D is 0, 40. And that's our answer. I hope that helped you work through a long answer style question as it would appear on the exam. And try the practice questions that come with this video and give yourself some chances to work with both linear functions and analytic geometry. And then you can do some self-check for how you did on those questions.